Hello everyone, and thank you all for watching my session on debugging Schrodinger's app at Conf42. So amazing to be here, and I look forward to geeking out with you all today. My name is DeveloperSteve. I'm one of the senior developer advocates at Lamigo. I'm going to talk more about my background in a moment. But first, some housekeeping. Hello from the past. First of all, hello from the past. Hope you are all well. Also, as we go through the presentation, please drop any comments, questions, and emojis into the chat if there is one, or reach out to me on social media. I always love connecting to folks and geeking out. With that in mind, I do have one thing to cover before we do get underway, and that is I have a disclaimer, and it has an asterisk, which makes it even more of a disclaimer. But the disclaimer is I love tech jokes. And I have a whole bunch of them. There's a couple that will be coming up during this presentation. I always love opening with them though, because it's important that we all keep smiling. This is an open source joke, so please make sure you share it amongst everyone. But how do fallen trees check for errors? Thinking music. Via log files. There we go. I didn't say they were good jokes, but all the same, please share amongst the community, and just someone that you may know that just needs to smile on, well, any time at all. Don't even need a reason. Anyway, hello again. My name is DeveloperSteve. I'm the senior developer advocate at Lamigo. I've been a developer advocate for many, many years now, and also writing code twice as long as that. Yeah, I'll have to do my math. Anyway, for a long time, let's say. But funny story, I've been doing developer advocacy. That's not a funny story, but kind of is, because I have a whole bunch of tech jokes. Anyway, I've been a developer advocate for many, many years now. And as such, I've been fortunate enough to connect to many tech communities throughout the world. And one of my favorite things is just being able to geek out and learn new things and share what I know and just help the communities do awesome things and all the amazing work that they do. But one of the things, I've done loads and loads of events through that as well. Over the years, people started calling me DeveloperSteve. It's my social media, I've been using it on social media for quite some time now. But so much so, when I got married in 2018, and we combined our surnames, so Coochin is my married name. When I legally changed my name, I thought, everyone's just been calling me, and I wonder if I can legally change my name to that. So turns out you can, and I did, and it's now my middle name. So yeah, there you go. Fun. That was the funny story. But like I said, I've been coding for many, many years now. Back in the days of QBasic, for those that remember it, on an Atari 800 XL. Yep. Taught myself QBasic, which, as the name suggests, it was fairly basic, but being relatively new to code myself, it did take some time to, understand the fundamentals on how the language worked and then what could be done with it. And you actually needed a lot of, just as an FYI, for those that haven't encountered it before, you needed a lot of basic to do, anything basic. Which, I guess that's called that for a reason, right? Humble beginnings of the industry. And also my developer origin story. But over the years, I've then gone on to work through a number of digital agencies, which I always loved because it's literally organized chaos. You have to take all sorts of requirements in zero time and build out all sorts of applications in zero time as well, and then support them beyond deployment. Whole other story and whole other talk right there. Shout out to anyone that is in digital agency world, because it is literally organized chaos sometimes. And hopefully that is not you. But one thing I took away from many projects as such is scaling applications is fundamental. It's fundamental in the very early stages of any application. And so you might be building that application for only 10 users now, but you have to build small now, but with big ideas later. And by that, I mean, you have to build out your application so that it can scale as the application adoption and the scalability is required as the app grows out. And if you think about it, that application that you're deploying now, or even that project that you're starting now with that idea or that very early client stage project, has to build for scale as the application requirements grow and also as its user base grows as well. that in a sense is, that's tech debt in a nutshell right there, because that application, if you pick that up as either a new dev or go back to a project that you've already started building out, building with that scalability in mind is fundamental to the application's longevity and to avoid that whole tech debt, and, or as I like to think of it, future-proofing for your future self. Now, the flip side of this is, and we've all been here too, is dealing with what I call the Friday night rule. So the Friday night rule is something that came about from all the hackathons I've done over the years, which is developers and teams sort of asking, which language should we build this particular function or this particular idea in? And so for me, sort of going back to digital agency days in particular, having the Friday night rule, which is, half a game into a particular online streaming game, or game, not streaming game, a particular game you might be playing, you might be halfway through a game and all of a sudden you get that alert saying application's down, or there's an issue, there's a problem with that deployed thing, needs to be fixed ASAP. Being able to avoid that is, the fundamental goal when it comes to deploying applications and keeping them stable, and more importantly, keeping our end users happy as well. Just going back to the Friday night rule too, with the which language should I use, I've always loved Python for many reasons, but in particular, its versatility and heavy lifting. And by that I mean, I've used it previously, and it's fundamentally great for these things and a whole bunch more, but game development, application development, of course, being able to build things out super quickly on very robust and matured ecosystem and framework tools and libraries, etc. And shout out to all the folks that help maintain and contribute to those too. And please contribute back wherever you can, because it keeps all our applications, contributing back keeps all our applications happy, and our end users happy too. That's always important. Anyway, game development is definitely one of the versatile things that I've used Python for previously. API development as well, given its Python's versatility, and also being a heavy lifting language. Well, I consider it to be heavy lifting. It can handle a whole bunch of tasks that you can throw at it, particularly in the API space. And I do love APIs. That's a whole other talk on its own right. Just speaking volumes to its heavy lifting nature, data sciences, very commonly used for any sort of analytical heavy lifting. And I've previously spent 10 years as a data analyst. So Python was definitely one of my go-to tools in my toolkit to be able to build out any manner of reporting, but also analytical understanding on huge data sets. It's always great for. Web, of course, Django, shout out to Django. And one of the application components we're going to be looking at today, Flask. For light demos and light application building, Flask is one of my total favorites to use. And one of my all-time favorites, MicroPython in IoT use as well, which is really cool. Actually, something I wanted to mention here that I've used it for previously. There's one time I bought a new coffee table and looked at it and thought, wow, that looks like a really big iPad. I should put 300 addressable LEDs in it. And so I did, using MicroPython and ESP32, and you can change the color of the lights, which is amazingly cool. Also, you can use Python, of course, on the back end of this too, to be able to do all the amazing coloring that you can see in this GIF here, which is always a fun project to do. Anyway, sort of going back to building for scalability, and this is where sort of something I've been thinking about a lot lately, how application deployment doesn't stop beyond that initial deployment. Because as developers, DevOps, and technologists, monitoring and sort of tracing and observing applications beyond deployment is equally as important. And if we think of Schrodinger's rules of observability, for example, which is essentially a thought experiment around quantum superposition, in that if you aren't observing something, it is both not happening and happening at the same time, because that particular element isn't being observed. If we apply that same logic to application development, if you aren't observing and monitoring the deployed application, then it both has errors and doesn't have errors at the same time, because you're not observing it to know that it's not having errors, so therefore it must also have errors too, which always hurts my head thinking about. But you know what I mean? Like, unless you're observing these applications beyond deployment, you don't know whether an error is being thrown, and perhaps a user on the other side of that error assumes that that's the way the application is supposed to work. As the end users of multiple of application, it's always something I see where there might be a little a button that you click and a certain thing happens quickly, but then it's redirected to another screen. Like, you can spot that as a developer, and be able to go, oh, that error is being thrown. Perhaps they don't know that is actually occurring. These are those type of instances where observability, monitoring, and tracing is able to help you identify that beyond deployment, and to make sure, well, fundamentally, that if those things are happening, you can cater for them in the application and be able to continue to refine your deployed app to make sure your users are kept happy and the application's kept happy too. Additionally, that could be using resources that it's costing you money essentially as well. So always something to be mindful of. Of course, building these apps locally, there's a number of ways to identify and spot issues inside code. And as devs, we fundamentally do it as well. So in using the core Python frameworks, for example, core debugging, we've got things like print, logging warning, and PDB that's able to identify. You can use to basically output breakpoints or certain highlighted parts of the code to be able to identify issues as they're occurring. There's also libraries as well, a multitude of libraries, like pprint, which I always love to do more extensive sort of output of issues and find things before my users find them and before they surface in production, because nobody wants that, particularly us maintaining and deploying said applications. Of course, our IDEs often use the same aforementioned methods to be able to surface those inside IDEs as you're building out these applications as well. So like VS Code, Eclipse, for example, all have built-in mechanisms to identify this sort of stuff. So that brings us to the first demo, because I thought we'd look at some ways to be able to output and identify issues. And that's essentially what Schrodinger's Python app does, is simulate these errors so we can see and understand as developers how you can identify and trace and monitor and will keep your app nice and happy and healthy. It also brings us to another tech joke potentially, but this is a Python one and you can see it on screen, spoilers. But what do you call 8 bits in Python? A snake bite. But yeah, this application, and I'll have the GitHub link for this at the end of the talk, so you can try it for yourself. Also, always looking for contributors too. So if you've got something you want added to the application, please open a pull request. But by all means, try it for yourself. There's 2 demos we'll be doing today. Spoilers. The first one I'm running locally to look at some of the output from the application. And the second one I've containerized and deployed to ECS, but we'll get into that in a little bit as well. Essentially, the app itself is built using Flask. I like Flask. I need to make that as a meme. I like Flask. Flask is great. Shout out to that community. I'm using Alchemy on the back end to do some very basic databasing. Didn't have a lot of complex databasing needs for it, so yeah, it's pretty light. And then there's a handful of routes to get us started. Actually, there's a few other ones, but these are some basic ones to get started. And this is a to-do application. So I can enter to-do items and then interact really, really easily just using some basic Flask routes, like get a list of to-dos, post a list of to-dos, update and delete as well. So that's the fundamentals of it. There's a couple other little fun ones that I've thrown in just to do more of that testing and sort of understanding of how errors are handled, not only through the infrastructure that this is the application's running on, but then also how your application can handle such things, and then also spotting and being able to identify these errors and warnings as they're flagged through. This does bring us to the first demo. So this is the application running locally. Oops, I actually don't have it running at the moment. There we go. Let's kick that off. Let's make sure, yep, it's all running okay. So this is the app. Like I said, there's a bunch of really basic routes like add, which is handled through a post, the basic get, which will get the list of, make sure that's running. That'll get the list of to-dos from the database, and then being able to see the output of all the routes being called and interacted with, which is also super important too, particularly locally development, but then we'll look at how that works on the cloud side of things in one minute. So if I create my first route, you can see in the terminal window there, it's basically showing, the route being called and then the response from it as well. So from the Flask server that's running, and you can see like HTTP status 200, like everything's okay. We can interact with that a number of ways. So that there was an update route, which basically just changes that particular database to-do entry listing. It changes the status flag on it so that it changes the status type, and as you can see, finished, not finished, then triggers as well. And of course, we can delete that as well. Now, I do have some fun special to-dos built into this as well for testing. So playing on the Schrodinger's cat paradigm, I have cat as a special task item. So you can see there the cat buttons now appeared as part of the cat entry listing. So if I click that now, what that'll do is incrementally start to go through the 400 HTTP statuses. So that just threw should have been a 400. And if I click that again, that will then start to iterate through different HTTP statuses as well. So it'll actually be throwing... why is that not through? There we go. Now it's throwing a 400. I don't know why. I think there was a redirect stuck there. Anyway, this is why tracing is important and monitoring, because you're able to identify this type of stuff. That should have thrown... there's a 401. All right, now it's working. See, I can use tracing to basically delve into that a little bit further. You can see now it's like there's a 402, there's a 403, so it's just going to incrementally shift through those. And as a deployed application, this helps me understand how my application will not only handle these, but how these errors appear in the infrastructure that I'm deploying on as well. And in this setup, it's fairly easy because, it's local and I can see what's going on. So if I do the other one I can do is HTTP stat, and I'm going to use HTTP status 418, one of my favorites. Rarely used other than in applications like this. But 418 is I'm a teapot as a HTTP status, which is totally one of my favorites because it doesn't really mean anything, but it's fun for testing. And you can see that I've basically was able to throw HTTP status 418, and I kind of knew what was causing it because I caused it to happen, which is fairly easy. Also, first demo worked. Hurrah! Well, it didn't work because it broke, but then it somehow fixed itself. But anyway, I think that was a caching issue inside the browser, I'm pretty sure. But let's just try that quickly again. 401. Yeah, see, now it's working. I reckon that was a caching issue because I hit a particular HTTP status, which was one of the not caching ones or do ignore ones. So yeah, anyway, fixed now. Hurrah. See, tracing, so easy. It's so helpful. Anyway, and to switch back to the deck. And special mention here too. So that was like working the application locally, but of course deploying to a cloud is a whole other story. Because that application, once deployed, may not necessarily be able to see what is happening behind the scenes as easily as what we're able to there. Although all those times that I've dug through so many server logs to find that one needle in that haystack to figure out what's going on with my application, the amount of hair that you pulled doing that whole exercise. Special mention here too. to all those times where you've got that error appearing in a deployed application, but you fundamentally, even to yourself, come back to that whole, but it was working on my machine. I've been here so many times, like having that error that we just had happen, which may have been a happy accident. Having that one error occur locally is completely different to having that happen on not only cloud infrastructure, but deployed cloud native application infrastructure. And by that, I mean when a cloud has a multitude of services that your application will use as part of a holistic application deployment. You might have a multiple of services connected now that are working completely fine, or at least behind the scenes seemingly aren't throwing any errors and seem to be working okay. But as we all know, as the industry changes and continues to grow, a lot of these applications not only get new functions and new approaches to how they work, but they may change without you realizing and potentially cause issues with your deployed application. Also, again, going back to the Friday night rule where you're half a game in, you get that message come through on that messaging app saying, hey, something's down, something's not right, something's broken. Murphy's Law suggests that it's probably going to happen in the most inconvenient time possible, either half a game in on a Friday night or at 2 a.m. Granted, it's probably going to be both, maybe, as well. We've all been there. We've all had that happen. This is where distributed tracing is able to help with this, because you can take a multitude of services consumed by being consumed by your application or running and empowering your application, and get a nice holistic map, traceable map of how those transactions interact with each of those different services. And if you think about it, like being able to sort of navigate that maze of multiple application sort of resource usage across a single transaction, it sort of simplifies the mapping of your application and its footprint across that cloud native service. What's really important and really fun here, though, is that one error that appears on that the most inconvenient Murphy's Law moment, you can then trace really easily as part of your holistic application map, which is really, really cool. Additionally, thanks to some industry standard approaches to tracing, monitoring, and logging now, you're able to also do that agentlessly as well. And by that I mean, and we've all been here too, you don't need to run an additional service anymore on server infrastructure or cloud infrastructure to be able to monitor and map those the full end-to-end tracing of those transactions across the multiple of cloud native application services as well. So you're able to get that holistic sort of application map and do it in an agentless approach and get that nice application cloud native footprint. Yes, agentless. And this is in part too, like I was saying, around the industry standard approach to a new approach called OpenTelemetry, which OpenTelemetry has been around, not only been around since 2019, but it's actually part of the Cloud Native Cloud Foundation as well, which is really cool because it takes a vendor-neutral approach, vendor-neutral open source approach to observability across application metrics, frameworks, and that whole community industry standard approach, which is fundamentally great because it means you don't need to get vendor locked in with your observability solution. And that is super important because friends don't let friends get vendor locked in, vendor neutral for the win. Yeah. OpenTelemetry, I won't go into this too much, but OpenTelemetry, it's quite extensive. They have the OpenTelemetry group have an amazing community, have some amazing write-ups, a multitude of blog posts, and they're always looking for contributors to the project as well. They actually have a Slack group too if anyone's looking to get involved or to connect to the community more there as well. But essentially, OpenTelemetry, even the instrumentation or libraries that can connect into your application, all vendor neutral, all industry standard. So you can take these and connect to whatever monitoring solutions you want, including some open source ones or some auto magical ones even that we'll be looking at in a little bit as well. But it takes that industry standard approach across a multiple of frameworks, a multiple of languages, and standardizes it, which is great. And I'm saying that as somebody that has not only run and deployed a number of services and cloud native applications over the years, but has also spent many, many, many hours delving through a multitude of logs looking for that one error that sometimes you just don't find, and you still have to figure out what your application's doing or what your application was trying to be doing. Special mention here too, and I've already mentioned it once, but you can never say it enough times, but this is completely the OpenTelemetry community, all open source, including all the amazing instrumentations you can see on the screen here too. So please, where possible, please make sure you are contributing back when you can as well. And so at Lamigo, one thing we always do is not only try and contribute back where we can to the OpenTelemetry community, but we also support a number of our own open source OpenTelemetry traces as well, which sometimes you need alongside auto instrumentation, depending on how you're auto tracing or how you're tracing your particular application. And so two languages that I wanted to mention here, of course, Python, because we're at a Python conference, and then there's this other language, which I won't talk about. But both of these are completely open sourced. We're always looking for contribs and ideas on how we can build these out and make them not only more robust, but a lot easier to use. We're going to be looking at one of those in a moment as well, because they're really easy to set up and very easy to deploy. Just quickly on that too, and again, going back to the previous slide where I said, please contribute where you can. But I live in rural Australia and I have sheep. So I affectionately called one Lambda recently because Lambda to lamb, I've always wanted to call a lamb that, and I now have a lamb. But Lambda to lamb, thanks you in advance for contribs and stars. And this is me holding said Lambda. Oh, isn't he cute? He's actually a lot heavier now. This was, he was only a couple months old, and he's about 7 months old now. So probs are not picking him up anymore. This is what happens when your lambdas get put on too much weight. Oh, it's probably a whole other joke there. These are really, because of the industry standard approach to OpenTelemetry, and again, going back to the vendor neutral approach as well, these are super easy to configure and install. I mean, you can use pip with Python. You just use pip to install the tracer library. Drop a reference into code. I'm going to show you what that is in a moment. Configure some environmental variables, because friends don't let friends, hard code and environmental things that can be environmental variables anyway. Namely hotel _service _name and Lamigo token tracer values as well. This version of the demo, I've taken the same application and containerized it and put it into ECS essentially. And also I've got a different to-do command set up to demonstrate interaction with SQS and how, simple queue service, and how that can fit into tracing to give you a better view of what your application is doing as well. So with that in mind, let's take a look at a demo, a second demo. So like I said, I'm using the Lamigo OpenTelemetry tracer, which you can see has been imported there. Alongside that, I've got some environmental variables set in this next demo, namely a whole bunch of keys and secret accesses, region name, and send queue URL for the AWS SQS service, which is part of this application. And of course, I've also made sure that I can handle those values not being set, which is all inside the app, but we'll have the link at the end. So stay tuned for that one. You can try it yourself. That's basically it. So just to be clear too, the Lamigo tracer or the OpenTelemetry tracer that I'm using here, like that is it. As other than calling the library in, I'm not adding any additional code because I don't need to. That's pretty much it. So it just runs inside the application and sends all those traces through. So So this is the ECS application I have running, the containerized application. It's pretty much the same as we saw before. I'll just refresh that. So I can send through a bunch of basic path invocations, which then will get surfaced inside our tracing service. So I have free tier Lamigo running here. And as you can see, it's already been tracing. I'm just going to refresh that screen. It's already been tracing the cluster and the app that I've got deployed there. By default, and like all I've had to do to get to like for this screen to happen, this monitoring to happen, is just connect the two platforms, which takes a second. There's a couple screens to go through as part of the free tier setup. What that library does is then add additional trace information as part of the application running. So if I click, I can click through to the application and see, or the application screen and see some more details about the cluster that's running. But then if I click on see traces, because I've got that tracer library running, I'll then be able to see more detailed information about what's happening behind the scenes. So you can see the services that I just, or the routes that I just called just then already creating invocation data to come through, be surfaced inside the OpenTelemetry monitoring. Now I can level that up a little bit more by not only using one of the functions that we were looking at in the last demo. So if I click cat again, that's going to start throwing a bunch of 400 errors like it did before. Hopefully this time with more maybe I was almost going to throw something. I think it's because it was a 402. Yeah, there we go. That's a 403. I can even do stats 418, which is I'm a teapot. No, it's definitely getting unhappy with I'm a teapot, so we will bail from that one. Let's go. So like I said, I have this other one set up that does SQS, essentially sends messages through to SQS as similar to what we've already been doing as well. So if I do meow, I then get a meow button, and that will then start sending messages through meow 1, meow 2, meow 3 to the SQS queue that I've got set up. And you can see there it looks to be working. But again, going back to the idea of Schrodinger's thought experiment, it appears to be working on the front end that I can see as an end user, but I don't necessarily know what it's doing on the back end because we've got that distributed cloud, that approach to deployment, that distributed application. So if we go back to our Explore, in fact, let's go to Transactions, the Transactions tab. You can see here there's some errors or some invocations which have started to appear from the stuff we've been doing inside our application. So you can see here there's 2 entries for 401, 402 is being thrown as part of the errors we're simulating. And then up here, those meow to-dos that we were just creating are actually picking up additional trace information, not only from our sort of base application, but any services that they then interact with as well. So you can see here the Flask application, all this great information that appears in it, is then also showing, as part of the transaction that was happening, showing a connection straight into SQS as well, which is really handy when you start to think about really large applications and the footprint that they can have across a multitude of services, not only within the same cloud, but associated services too, like sending SMS, sending emails, or if you're dealing with an e-commerce application, also transactional systems like Square or Stripe, for example, and how those services interact. And for e-commerce applications, you totally want to be monitoring for this sort of activity because you want to make sure that, again, everything's working on the back end and your users are having the best possible application experience they can. So anyway, hurrah, the demo number 2 worked. I'm almost out of time, so I'm just going to wrap up with a few more slides here. Just some takeaways to close on, but always be building for scale, or ABS as I like to think of it. From the initial onset, make sure you're building with that scale and growth mindset for your application in mind, and making sure that everything will handle minimal users now and maximum users later with a little refactor in between. Always be future-proofing yourself. Rinse, repeat, and refine. Just make sure, again, that you're identifying issues that occur, and also ways that you can always improve your application, because it's going to make that experience so much better and make your application run smoother as well. And most importantly, make sure you trace and monitor everything you possibly can to make sure everything's working as it potentially should. Code's available on here on my GitHub as well, so please go check that out. Always looking for contribs, stars, and comments, so please reach out on socials if you have any issues or anything you wanted to add. Just lastly, please always remember to use your tech superpowers for good and be excellent to each other. Thank you very much.